Hello dear students, welcome to the lecture 3 of software engineering course. So today's topic is Agile software development. Part 1. Topics covered.
Agile methods, plan-driven and agile development, extreme programming, agile project management, scaling agile methods.
Okay, so let's start. Rapid software development.
Rapid development and delivery is now often the most important requirement for software systems. Businesses operate in a fast-changing requirement, and it is practically impossible to produce a set of stable software requirements. Software has to evolve quickly to reflect changing business needs. Rapid software development, specification, design and implementation are interleaved. System is developed as a series of versions with stakeholders involved in version evaluation. User interfaces are often developed using an IDE and graphical toolset.
Okay, so in rapid software development, design and implementation is done at the same time. You constantly get the feedback of your customers, so you make changes according to your customer needs and demands, and you use ready tools and IDA to develop your interface so that you can develop your interface much quicker. Agile methods.
Dissatisfaction with the overheads involved in software design methods of the 1980s and 1990s led to the creation of Agile methods. These methods focus on the code rather than the design, are based on an iterative approach to software development, are intended to deliver working software quickly and evolve this quickly to meet changing requirements. The aim of Agile methods is to reduce overheads in the software process, e.g., by limiting documentation, and to be able to respond quickly to changing requirements without excessive rework.
So with the agile development methods, we aim to reduce overheads such as documentation. Documentation is a huge task that takes huge amount of time. Believe me, if you do that in a big project, you will know it. And so when you reduce the documentation, your speed increases, and you develop your software in a way that it can be changed quickly according to your customers demands. Okay, Agile manifesto.
We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. Responding to changeover following a plan. That is, while there is value in the items on the right, we value the items on the left more.
Okay, so the principles of agile methods.
Customer involvement. Customers should be closely involved throughout the development process. Their role is provide and prioritize new system requirements and to evaluate the iterations of the system.
Okay, so this is the customer involvement. Incremental delivery.
Incremental delivery. The software is developed in increments with the customer specifying the requirements to be included in each increment.
People not process.
People not process. The skills of the development team should be recognized and exploited. Team members should be left to develop their own ways of working without prescriptive processes.
Okay. Embrace change.
Embrace change, expect the system requirements to change and so design the system to accommodate these changes.
Maintain simplicity.
Maintain simplicity, focus on simplicity in both the software being developed and in the development process. Wherever possible, actively work to eliminate complexity from the system.
So you see, in an agile development, you make some sacrifices to develop your software more rapidly. Can you do that in a critical health critical system? No. In a health critical system, uh, if you sacrifice some of the requirements, you may end up with more hazardous systems and health damaging systems. However, let's say you are developing a game, you can very well use agile methods because an error in a game can be fixed later without almost any loss of money or any hazard to the health or such things. So based on your software, you need to choose your development way. There is not a single development way, development method that fits to every kind of software. Okay, every kind of task.
Agile method applicability.
So this is what I mean.
Product development, where a software company is developing a small or medium-sized product for sale. Custom system development within an organization, where there is a clear commitment from the customer to become involved in the development process and where there are not a lot of external rules and regulations that affect the software. Because of their focus on small, tightly integrated teams, there are problems in scaling agile methods to large systems.
Okay.
Problems with agile methods. It can be difficult to keep the interest of customers who are involved in the process. Team members may be unsuited to the intense involvement that characterizes agile methods. Prioritizing changes can be difficult where there are multiple stakeholders. Maintaining simplicity requires extra work. Contracts may be a problem as with other approaches to iterative development. Agile methods and software maintenance. Most organizations spend more on maintaining existing software than they do on new software development. So, if agile methods are to be successful, they have to support maintenance as well as original development. Two key issues are systems that are developed using an agile approach maintainable, given the emphasis in the development process of minimizing formal documentation. Can agile methods be used effectively for evolving a system in response to customer change requests? Problems may arise if original development team cannot be maintained.
Why is that? Because if you are not making an intensive documentation and when your developer leaves your company, the next developer will be have to figure out on its own what does that code means or what does that method means and such things because there isn't enough documentation. Okay, so this problem may arise.
Plan-driven and agile development. Plan-driven development, a plan-driven approach to software engineering is based around separate development stages with the outputs to be produced at each of these stages planned in advance. Not necessarily waterfall model, plan-driven, incremental development is possible. Iteration occurs within activities.
So here we are seeing the difference of plan-driven and agile development.
Agile development, specification, design, implementation and testing are interleaved and the outputs from the development process are decided through a process of negotiation during the software development process.
It is not planned in advance. Okay. In agile development, what is going to be done is planned in advance. It is being decided during the development.
Plan-driven and agile specification.
Okay, so plan-based development requirements, you see it is looping. So the requirements may update requirements from the feedback of design and implementation. You see it here. Design and implementation feedbacks the requirements engineering. Requirements specification is feedbacked by requirements engineering, and design and implementation is feedbacked by requirements specification. So everything, almost everything feedbacks itself and previous stage, so they are constantly updated during the plan-based development. And in agile development, there is only two stages: requirements engineering that feedbacks design and implementation, and design and implementation feedbacks requirements engineering. It is much simpler, much faster, and however it has some downsides. Okay.
Technical, human, organizational issues. Most projects include elements of plan-driven and agile processes. Deciding on the balance depends on Is it important to have a very detailed specification and design before moving to implementation? If so, you probably need to use a plan-driven approach. Is an incremental delivery strategy, where you deliver the software to customers and get rapid feedback from them, realistic? If so, consider using agile methods. How large is the system that is being developed? Agile methods are most effective when the system can be developed with a small co-located team who can communicate informally. This may not be possible for large systems that require larger development teams, so a plan-driven approach may have to be used.
For example, let's say you are going to develop the software of a NASA project. Okay, a project that will go to, let's say, Mars. Can you develop the Mars project in an agile development, or let's say you are going to develop a car software? Car softwares are extremely big, millions of lines of code. Can you do that in an agile development? No. These are very big projects. There will be many different teams, and it has to be extremely well planned and managed. However, let's say you are going to develop a mobile game and you have a team of like 5 or 10 person. You can very well develop this game in an agile development because the errors is not fatal as like the NASA project, and you can communicate informally. All of you can work in a single place and such things. So you have to choose your method based on the software you are going to develop. Being a software engineer is actually this. If you are a good software engineer, you know which method is best suited for your task, okay, for your job. So this will make a difference between you and between a regular programmer, a regular coder. Okay, so being a software engineer means that you know how to code, but you also know how to code well. Okay, how to manage the development process well.
Technical, human, organizational issues. What type of system is being developed? Plan-driven approaches may be required for systems that require a lot of analysis before implementation, e.g., real-time system with complex timing requirements. What is the expected system lifetime? Long lifetime systems may require more design documentation to communicate the original intentions of the system developers to the support team. What technologies are available to support system development? Agile methods rely on good tools to keep track of an evolving design. How is the development team organized? If the development team is distributed or if part of the development is being outsourced, then you may need to develop design documents to communicate across the development teams. Technical, human, organizational issues. Are there cultural or organizational issues that may affect the system development? Traditional engineering organizations have a culture of plan-based development, as this is the norm in engineering. How good are the designers and programmers in the development team? It is sometimes argued that Agile methods require higher skill levels than plan-based approaches in which programmers simply translate a detailed design into code.
Actually, this is true. In an agile development, to develop rapidly, the engineer or the developer has to be skilled enough to figure out things on its own, to complete the tasks in a good way, in a sufficient way on its own. They have to be skilled enough. They have to have enough experience. Okay.
Is the system subject to external regulation? If a system has to be approved by an external regulator, e.g. the FAA approves software that is critical to the operation of an aircraft, then you will probably be required to produce detailed documentation as part of the system safety case.
Yes, of course. Let's say you are going to develop a software for an MR device, okay, magnetic resonance MR device. Let me show you. You can't just develop it without proper documentation, okay, because the government wouldn't likely to let you use your device on humans, and they would require you to document everything and prove that your device is safe to use and such things. So external regulations are also a very important part to decide whether you can use agile development or not.
Extreme programming. Perhaps the best known and most widely used Agile method.
So extreme programming is a method of agile development.
Extreme programming (XP) takes an extreme approach to iterative development. New versions may be built several times per day. Increments are delivered to customers every 2 weeks. All tests must be run for every build, and the build is only accepted if tests run successfully.
So in extreme programming, you need to have a good testing methodology so that you can automatically, yes, you should have automatic testing. You can automatically test every case after each, let's say, increment and see whether there are any errors or all the systems are working fine as intended.
XP and Agile principles. Incremental development is supported through small, frequent system releases. Customer involvement means full-time customer engagement with the team. People not process through pair programming, collective ownership, and a process that avoids long working hours. Change supported through regular system releases. Maintaining simplicity through constant refactoring of code.
This is also a hard thing because refactoring is taking time and it is uh, uh, hard to do effectively, and let's say, in a good way. Okay.
The extreme programming release cycle.
Alright, so select user stories for this release, break down stories to tasks, plan release, develop integrate test software, release software, evaluate system. So it is a cycle, and each time it plans what needs to be done, select user stories for this release, and then break that what needs to be done into the tasks so that you can accomplish it. Make a planned release quickly, then develop integrate test software for that planned release, release the software, evaluate the system, and get user feedback again, and start doing the next, start working on the next task. Okay.
Extreme programming practices.
Principle or practice and description.
Incremental planning. Requirements are recorded on story cards, and the stories to be included in a release are determined by the time available and their relative priority. The developers break these stories into development tasks.
So you see it says see figures in 3.5 and 3.6. These figures are from the Software Engineering 9th edition book, which we are using as a source. You can also click this source to see where I did get these slides. Okay. Uh, However, for our course, if they are necessary, I put them on the slides, or if not, you can check the book yourself.
Small releases. The minimal useful set of functionality that provides business value is developed first. Releases of the system are frequent and incrementally add functionality to the first release. Simple design. Enough design is carried out to meet the current requirements and no more. Test-first development. An automated unit test framework is used to write tests for a new piece of functionality before that functionality itself is implemented.
This is really important. For every functionality that you add, you need to uh, code an automated unit test so that that functionality can be tested before the release, and with the all tests of previous releases, so that you will know that whether your new release breaks any feature of the existing system, and this way you can ensure that you are not making big mistakes, and this has to be automated so that you won't be spending extra time with retesting each time. Okay.
Refactoring. All developers are expected to refactor the code continuously as soon as possible code improvements are found. This keeps the code simple and maintainable.
So what is refactoring the code? If you wonder.
In computer programming and software design, code refactoring is the process of restructuring existing computer code, changing the factoring, without changing its external behavior. Refactoring is intended to improve the design, structure, and/or implementation of the software, while preserving its functionality.
So basically, refactoring is improving your coding. Okay. Improving your code design, code structure, code design, so that it can be maintained easily and in a better way. Okay. Okay. And so extreme programming practices be?
Pair programming. Developers work in pairs, checking each other's work and providing the support to always do a good job. Collective ownership. The pairs of developers work on all areas of the system, so that no islands of expertise develop and all the developers take responsibility for all of the code. Anyone can change anything. Continuous integration. As soon as the work on a task is complete, it is integrated into the whole system. After any such integration, all the unit tests in the system must pass. Sustainable pace. Large amounts of overtime are not considered acceptable, as the net effect is often to reduce code quality and medium-term productivity. On-site customer. A representative of the end-user of the system, the customer, should be available full-time for the use of the XP team. In an extreme programming process, the customer is a member of the development team and is responsible for bringing system requirements to the team for implementation. Requirements scenarios. In XP, a customer or user is part of the XP team and is responsible for making decisions on requirements. User requirements are expressed as scenarios or user stories. These are written on cards and the development team break them down into implementation tasks. These tasks are the basis of schedule and cost estimates. The customer chooses the stories for inclusion in the next release based on their priorities and the schedule estimates.
So basically, in extreme programming, the customer is the main driving element of the development. The customer requests something and that is being developed before other things are being developed. So the customer decides what to be developed next. Okay, customer is extremely important in XP programming. Okay.
A prescribing medication story. Prescribing medication. Kate is a doctor who wishes to prescribe medication for a patient attending a clinic. The patient record is already displayed on her computer, so she clicks on the medication field and can select current medication, new medication, or formulary.
So here we are making definition of a system that needs to be developed. Okay. So the customer is defining what needs to be done to us. Let's read again.
Kate is a doctor who wishes to prescribe medication for a patient attending a clinic. The patient record is already displayed on her computer, so she clicks on the medication field and can select current medication, new medication, or formulary. If she selects current medication, the system asks her to check the dose. If she wants to change the dose, she enters the dose and then confirms the prescription. If she chooses new medication, the system assumes that she knows which medication to prescribe. She types the first few letters of the drug name. The system displays a list of possible drugs starting with these letters. She chooses the required medication and the system responds by asking her to check that the medication selected is correct. She enters the dose and then confirms the prescription. If she chooses formulary, the system displays a search box for the approved formulary. She can then search for the drug required. She selects a drug and is asked to check that the medication is correct. She enters the dose and then confirms the prescription. The system always checks that the dose is within the approved range. If it isn't, Kate is asked to change the dose. After Kate has confirmed the prescription, it will be displayed for checking. She either clicks OK or Change. If she clicks OK, the prescription is recorded on the audit database. If she clicks on Change, she re-enters the prescribing medication process.
Okay. So this is a general description of the necessary software that needs to be developed. Okay. This description includes many of the features of the software from the, let's say, customer. So based on the customer's example story, the developers can develop that software.
Examples of task cards for prescribing medication. Task 1, change dose of prescribed drug. Task 2, formulary selection. Task 3, dose checking. Dose checking is a safety precaution to check that the doctor has not prescribed a dangerously small or large dose. Using the formulary ID for the generic drug name, look up the formulary and retrieve the recommended maximum and minimum dose. Check the prescribed dose against the minimum and maximum. If outside the range, issue an error message saying that the dose is too high or too low. If within the range, enable the Confirm button. XP and change. Conventional wisdom in software engineering is to design for change. It is worth spending time and effort anticipating changes as this reduces costs later in the life cycle. XP, however, maintains that this is not worthwhile as changes cannot be reliably anticipated. Rather, it proposes constant code improvement, refactoring, to make changes easier when they have to be implemented. Refactoring. Programming team look for possible software improvements and make these improvements even where there is no immediate need for them. This improves the understandability of the software and so reduces the need for documentation. Changes are easier to make because the code is well structured and clear. However, some changes requires architecture refactoring and this is much more expensive. Examples of refactoring. Reorganization of a class hierarchy to remove duplicate code. Tidying up and renaming attributes and methods to make them easier to understand. The replacement of inline code with calls to methods that have been included in a program library.
As a being software engineer, you should never use duplicate inline code. Make that inline code into a method and make a call to that method. This way, your code will be more organized. You will prevent copy and pasting same code, or when you make a change to your code, it will be effective in the all places that code is being used and such things. So we should always code our software as much as with methods, frameworks, and DLL files and such. Key points of the part 1.
Key points. Agile methods are incremental development methods that focus on rapid development, frequent releases of the software, reducing process overheads and producing high-quality code. They involve the customer directly in the development process. The decision on whether to use an agile or a plan-driven approach to development should depend on the type of software being developed, the capabilities of the development team and the culture of the company developing the system.
So this is really important. Being a software engineer, you will decide whether to use plan-driven approach or agile development approach. Okay.
Extreme programming is a well-known agile method that integrates a range of good programming practices such as frequent releases of the software, continuous software improvement, and customer participation in the development team.
So to be able to do extreme programming, your customer has to be involved in your development process. Okay, Agile Software Development Part 2.
Testing in XP.
XP is Extreme Programming.
Testing is central to XP, and XP has developed an approach where the program is tested after every change has been made.
So testing is a central part of Extreme Programming.
XP testing features: test-first development, incremental test development from scenarios, user involvement in test development and validation. Automated test harnesses are used to run all component tests each time that a new release is built.
Okay.
Test-first development. Writing tests before code clarifies the requirements to be implemented. Tests are written as programs rather than data so that they can be executed automatically. The test includes a check that it has executed correctly. Usually relies on a testing framework such as Junit. All previous and new tests are run automatically when new functionality is added, thus checking that the new functionality has not introduced errors.
Okay, so there is a key point here. Writing tests before code clarifies the requirements to be implemented. So let's say you want your software to be able to check whether given amount of drug is above the threshold or not. So you write a test for this, and let's say when you provide 1000 milligram, you want software to return threshold exceeding error, and when you give 10 milligram, you want your software to return low amount of those errors. So you write this test, and when you run this test, you know what will your software will return. So based on that, you can code your software based on the test. So it clarifies the requirements for the programmer.
Customer involvement. The role of the customer in the testing process is to help develop acceptance tests for the stories that are to be implemented in the next release of the system. The customer, who is part of the team, writes tests as development proceeds. All new code is therefore validated to ensure that it is what the customer needs. However, people adopting the customer role have limited time available and so cannot work full-time with the development team. They may feel that providing the requirements was enough of a contribution and so may be reluctant to get involved in the testing process. Test case description for dose checking.
Okay, so the customer provides us a description of dose checking, and let's read it.
Input 1. A number in mg representing a single dose of the drug. 2. A number representing the number of single doses per day. Tests 1. Test for inputs where the single dose is correct but the frequency is too high. 2. Test for inputs where the single dose is too high and too low. 3. Test for inputs where the single dose times frequency is too high and too low. 4. Test for inputs where single dose times frequency is in the permitted range. Output, OK or error message indicating that the dose is outside the safe range.
Okay, test automation.
Test automation means that tests are written as executable components before the task is implemented. These testing components should be standalone, should simulate the submission of input to be tested, and should check that the result meets the output specification. An automated test framework, e.g. JUnit, is a system that makes it easy to write executable tests and submit a set of tests for execution.
So let's look for a JUnit. And let's see the JUnit description.
JUnit is a unit testing framework for the Java programming language. JUnit has been important in the development of test-driven development, and is one of a family of unit testing frameworks which is collectively known as XUnit that originated with Sonnet.
Okay, so JUnit is a unit testing framework for Java programming language. Let's see for C#, if there's any. Okay, yes, looks like there is an unit which belongs to the same testing family.
Nunit is a unit testing framework that belongs to the XUnit family, and it is written entirely in C#. Several unit testing frameworks which derive their design and functionality from Smalltalk's Sonnet are collectively named as XUnit. It provides support for all .NET languages, and it serves the same purpose as JUnit does for Java. It is an open-source software which was initially ported from JUnit. The current production release is version 3 and has been completely rewritten to offer many new features.
And there are also other unit testing frameworks like for JavaScript or C++ and for Java. And also there is this description, let's read it.
What is unit testing? Unit testing is a way of testing the smallest piece of code referred to as a unit that can be logically isolated in a system. A unit is the smallest testable part of any software that has one or more inputs and a single output. Each unit is tested to validate that the software performs as desired. Unit testing is mainly focused on the functional correctness of standalone modules. Find list of 5 best unit testing frameworks to automate unit tests. Unit testing is a type of software testing where individual components of code get tested. This is to make sure that each unit is performing the way it should. Unit testing is the smallest part of the software that you can test. It usually involves 1 or 2 inputs that result in a single output. There are 2 types of unit testing, manual and automated. Automated is generally the preferred method as it saves the developer a lot of time and effort. To do unit testing, your developer needs to write clear test code to test a specific function against an expected outcome. The tests will then run, and any errors or failures to produce the expected outcome will be logged.
It may become too unlogical to write unit tests that will give you the correct results. Let's say you have coded a method that takes 3 integer arguments and returns something based on that. And when you first coded a unit test for this, of course, it will work as expected. However, imagine that that particular method calls another method, and you later, much later, let's say 5 months later, you are making a code changes to the called method inside that method, and it breaks your parent method behavior. However, you wouldn't know it until your unit test runs and this time fails. So do you understand what I mean? When you make changes to lots of methods and other methods or libraries that depends on those changed methods may get broken over the time, and the best way of knowing such code breakings is having automated unit tests. And imagine that you have a very big company that hundreds of developers are working on different tasks. Each one can break others' codings unintentionally, and catching all these coding changes, the best way is unit testing, automated unit testing.
As testing is automated, there is always a set of tests that can be quickly and easily executed. Whenever any functionality is added to the system, the tests can be run and problems that the new code has introduced can be caught immediately.
Yes, this is the actually main reason of automated unit testing. Whenever you code a new functionality, make a change, you run all of the tests and you see that whether any existing code in the system is existing functionality in the system is broken or not. It's a great way.
XP testing difficulties. Programmers prefer programming to testing, and sometimes they take shortcuts when writing tests. For example, they may write incomplete tests that do not check for all possible exceptions that may occur. Some tests can be very difficult to write incrementally. For example, in a complex user interface, it is often difficult to write unit tests for the code that implements the display logic and workflow between screens. It's difficult to judge the completeness of a set of tests. Although you may have a lot of system tests, your test set may not provide complete coverage. Pair programming. In XP, programmers work in pairs, sitting together to develop code. This helps develop common ownership of code and spreads knowledge across the team. It serves as an informal review process as each line of code is looked at by more than one person. It encourages refactoring as the whole team can benefit from this. Measurements suggest that development productivity with pair programming is similar to that of two people working independently.
So you gain benefits, many benefits, and you don't lose any productivity with pair programming.
In pair programming, programmers sit together at the same workstation to develop the software. Pairs are created dynamically so that all team members work with each other during the development process. The sharing of knowledge that happens during pair programming is very important as it reduces the overall risks to a project when team members leave. Pair programming is not necessarily inefficient, and there is evidence that a pair working together is more efficient than two programmers working separately.
So pair programming is a really good thing. However, there may be some negative sides. Let's first read the advantages.
Advantages of pair programming. It supports the idea of collective ownership and responsibility for the system. Individuals are not held responsible for problems with the code. Instead, the team has collective responsibility for resolving these problems. It acts as an informal review process because each line of code is looked at by at least two people. It helps support refactoring, which is a process of software improvement. Where pair programming and collective ownership are used, others benefit immediately from the refactoring, so they are likely to support the process.
Agile project.
Agile project management.
Okay, so what could be the disadvantage of pair programming? Do you think? What could be? In pair programming, you need to make two developers work together, and that is the hardest part because they need to sit by each other, they need to work collaboratively on the same code, and it is the hardest thing to achieve in pair programming. And they also need to have similar uh, coding skills, coding experience. However, if you can achieve to make two or more developers work on the same code sitting side by side, then you can achieve all the benefits of pair programming and ensure that your project will not fail even if one of the programmer or several of them leaves the project. Okay. So Agile project management.
The principal responsibility of software project managers is to manage the project so that the software is delivered on time and within the planned budget for the project. The standard approach to project management is plan-driven. Managers draw up a plan for the project showing what should be delivered, when it should be delivered, and who will work on the development of the project deliverables. Agile project management requires a different approach, which is adapted to incremental development and the particular strengths of Agile methods.
So of course, the management of Agile programming would be different than plan-based programming. Okay.
Scrum. The Scrum approach is a general Agile method, but its focus is on managing iterative development rather than specific Agile practices. There are 3 phases in Scrum. The initial phase is an outline planning phase where you establish the general objectives for the project and design the software architecture. This is followed by a series of sprint cycles, where each cycle develops an increment of the system. The project closure phase wraps up the project, completes required documentation such as system help frames and user manuals, and assesses the lessons learned from the project. The Scrum process.
Outline planning and architectural design, and there is a loop of process, sprint cycle, assess, select, develop, review, assess, select, develop, review. Okay, and then once the project is completed, project closure. Okay.
The sprint cycle. Sprints are fixed length, normally 2 to 4 weeks. They correspond to the development of a release of the system in XP. The starting point for planning is the product backlog, which is the list of work to be done on the project. The selection phase involves all of the project team who work with the customer to select the features and functionality to be developed during the sprint.
And when we type Scrum to the Google, okay, you see there are a lot of results for Scrum because it is extremely popular method. So you can get more idea from Scrum on the resources on the internet, from the resource on the internet. Okay. You see Atlassian.com, Agile Scrum.
What is Scrum? Scrum is a framework that helps teams work together. Much like a rugby team, where it gets its name, training for the big game, Scrum encourages teams to learn through experiences, self-organize while working on a problem, and reflect on their wins and losses to continuously improve. While the Scrum I'm talking about is most frequently used by software development teams, its principles and lessons can be applied to all kinds of teamwork. This is one of the reasons Scrum is so popular. Often thought of as an agile project management framework, Scrum describes a set of meetings, tools, and roles that work in concert to help teams structure and manage their work.
So you may read this article if you want. There are sprints, sprint planning for agile ceremonies, teams, fight, and you see other, perhaps the other processes. Okay.
But why Scrum? The Scrum framework itself is simple. The rules, artifacts, events, and roles are easy to understand. Its semi-prescriptive approach actually helps remove the ambiguities in the development process, while giving sufficient space for companies to introduce their individual flavor to it. The organization of complex tasks into manageable user stories makes it ideal for difficult projects. Also, the clear demarcation of roles and planned events ensure that there is transparency and collective ownership throughout the development cycle. Quick releases keep the team motivated and the users happy as they can see progress in a short amount of time. However, Scrum could take time to master, especially if the development team is acclimatized to a typical waterfall model. The concepts of smaller iterations, daily Scrum meetings, sprint reviews, and identifying a Scrum master could be a challenging cultural shift for a new team. But, the long-term benefits far outweigh the initial learning curve. Scrum's success in developing complex hardware and software products across diverse industries and verticals makes it a compelling framework to adopt for your organization.
Okay, so this article is posted on Atlassian. Atlassian is a very big, let's say, company. It also owns, for example, Bitbucket. Bitbucket is a code management system that is as much as popular as GitHub. So this is not some simple or small company, because software engineering is being used. The methods in software engineering is being used by all the major companies. Okay, so never think. So big companies are using the methods, the approaches we show in this course. Never think that this course is useless. This course, you will understand the importance of software engineering course when you start your professional career. Okay, because big companies, or let's say corporates, are always using the best practices that are available, and the practices that let them to manage more than one programmers, developers. So you will see the importance of this course in the real life when you start your professional career. Okay.
The sprint cycle. Sprints are fixed length, normally 2 to 4 weeks. They correspond to the development of a release of the system in XP. The starting point for planning is the product backlog, which is the list of work to be done on the project. The selection phase involves all of the project team who work with the customer to select the features and functionality to be developed during the sprint.
So during the sprint, they develop a release of a product. Okay. Sprint cycle
Once these are agreed, the team organize themselves to develop the software. During this stage, the team is isolated from the customer and the organization, with all communications channeled through the so-called Scrum Master. The role of the Scrum Master is to protect the development team from external distractions. At the end of the sprint, the work done is reviewed and presented to stakeholders. The next sprint cycle then begins.
Teamwork in Scrum.
The Scrum Master is a facilitator who arranges daily meetings, tracks the backlog of work to be done, records decisions, measures progress against the backlog, and communicates with customers and management outside of the team. The whole team attends short daily meetings where all team members share information, describe their progress since the last meeting, problems that have arisen, and what is planned for the following day. This means that everyone on the team knows what is going on and, if problems arise, can re-plan short-term work to cope with them.
The benefits of Scrum.
The product is broken down into a set of manageable and understandable chunks. Unstable requirements do not hold up progress. The whole team have visibility of everything, and consequently team communication is improved. Customers see on-time delivery of increments and gain feedback on how the product works. Trust between customers and developers is established, and a positive culture is created in which everyone expects the project to succeed. Scaling Agile methods. Agile methods have proved to be successful for small and medium-sized projects that can be developed by a small co-located team. It is sometimes argued that the success of these methods comes because of improved communications, which is possible when everyone is working together. Scaling up Agile methods involves changing these to cope with larger, longer projects where there are multiple development teams, perhaps working in different locations. Large systems development. Large systems are usually collections of separate, communicating systems, where separate teams develop each system. Frequently, these teams are working in different places, sometimes in different time zones. Large systems are brownfield systems, that is, they include and interact with a number of existing systems. Many of the system requirements are concerned with this interaction and so don't really lend themselves to flexibility and incremental development. Where several systems are integrated to create a system, a significant fraction of the development is concerned with system configuration rather than original code development. Large systems and their development processes are often constrained by external rules and regulations limiting the way that they can be developed. Large systems have a long procurement and development time. It is difficult to maintain coherent teams who know about the system over that period as, inevitably, people move on to other jobs and projects. Large systems usually have a diverse set of stakeholders. It is practically impossible to involve all of these different stakeholders in the development process. Scaling out and scaling up. Scaling up is concerned with using Agile methods for developing large software systems that cannot be developed by a small team. Scaling out is concerned with how Agile methods can be introduced across a large organization with many years of software development experience. When scaling Agile methods, it is essential to maintain Agile fundamentals, flexible planning, frequent system releases, continuous integration, test-driven development, and good team communications. Scaling up to large systems. For large systems development, it is not possible to focus only on the code of the system. You need to do more upfront design and system documentation. Cross-team communication mechanisms have to be designed and used. This should involve regular phone and video conferences between team members and frequent, short electronic meetings where teams update each other on progress. Continuous integration, where the whole system is built every time any developer checks in a change, is practically impossible. However, it is essential to maintain frequent system builds and regular releases of the system. Scaling out to large companies. Project managers who do not have experience of Agile methods may be reluctant to accept the risk of a new approach. Large organizations often have quality procedures and standards that all projects are expected to follow, and, because of their bureaucratic nature, these are likely to be incompatible with Agile methods. Agile methods seem to work best when team members have a relatively high skill level. However, within large organizations, there are likely to be a wide range of skills and abilities. There may be cultural resistance to Agile methods, especially in those organizations that have a long history of using conventional systems engineering processes.
Okay, so let's say you're a large company, but you want to scale out to agile methods. Then you get these challenges to be solved to let your team, let your engineers work as in the agile method. And let's say you are a small system and you want to scale up to a large system, then you got these challenges to solve them. And so there is a scaling out and scaling up. Scaling out is from large company to uh, start using agile methods as small teams, and scaling up is from small teams and from agile development to large projects, large systems with plan-driven approach. Both have some challenges in their way. Okay, key points of the lecture.
A particular strength of extreme programming is the development of automated tests before a program feature is created. All tests must successfully execute when an increment is integrated into a system. The Scrum method is an agile method that provides a project management framework. It is centered around a set of sprints, which are fixed time periods when a system increment is developed. Scaling agile methods for large systems is difficult. Large systems need upfront design and some documentation.
So to be able to use extreme programming, you need to be able to uh, program your software as in increments, and they should be testable. So if your software cannot be splitted into increments, you cannot use extreme programming. In the Scrum method, the Scrum method actually provides a project management framework, and with that project management, you can develop your software in more efficiency and in lesser time. Scaling agile methods for large systems is difficult. We saw the reasons. Okay, for this week, this is enough. Hopefully, see you next week. I am going to upload the lecture slides to our GitHub repository. I'm expecting volunteers to correct the automatically generated subtitles for this video. Uh, Also, on this course, I will give you a project, and to do that project, you will be needed to learn how to use a code management repository such as GitHub or Bitbucket or alternatives with a code management software such as Gitbash I am using. I will make 1 second. Okay, so we thank you. We thank the Oktay Levent for fixing our subtitles. Okay, let's check our GitHub repository, see whether it is updated or not. Okay, it will be arrived here, updated, refresh. Yes, you see updated 10 seconds ago. And when I go, I will see in the lecture slides. Okay. Okay, hopefully see you next week. Stay safe. End of lecture.